So the brand new Arduino UnoQ is finally here, and it's not just another update. This thing is a total game changer, completely rethinking what a maker board can even be. It's packing two powerful brains into one very familiar package. Let's break down what that actually means.
But before we get into the new hotness, let's just back up for a second. When you hear the word Arduino, what kind of project immediately pops into your head?
For years, it's been the go-to board for projects just like these, right? Simple stuff, super reliable, and absolutely perfect for learning your way around electronics and coding. This is the board that launched a million different projects. But what if all of that, everything we just saw, was just the warm-up act? With the new Arduino UnoQ, it turns out that everything we thought we knew about Arduino was really only half the story.
Okay, let's get into the good stuff. The UnoQ isn't just one thing, it's two incredibly powerful processors. Basically two brains, working together on a single board.
What we're looking at here is a true hybrid, built from the ground up. It's designed to handle complex, high-level thinking, and at the exact same time handle those immediate, real-time actions you need for physical projects, like spinning a motor or reading a sensor with perfect, repeatable timing.
First up, you've got the microcontroller, an STM32 chip. Now, the best way to think about this is like the board's brainstem. It's all about instinct. It doesn't sit around and think about things. It just reacts instantly and predictably to what's happening in the real world. And then you have the other side of the coin, the single board computer, powered by a seriously beefy Qualcomm chip. If the first part was the brainstem, this is the cerebral cortex. This is the intelligent, thinking part of the brain. It's running a full-blown Debian Linux operating system, which means it can run complex software, analyze data, and make some pretty sophisticated decisions.
And this division of labor, this is the secret sauce. You've got the MCU running a real-time OS, handling all that precision timing with zero delay. And, at the same time, the SBC is just chugging away on Linux, free to manage the complicated apps and do all the heavy thinking. They each do what they're best at, and that creates a pretty much perfect partnership.
So you might be wondering, okay, this is cool, but why now? Why does a board like this even exist? Well, the answer isn't just about cool new tech. It's about a huge strategic shift that's happening in the tech world.
See, this board didn't just appear out of nowhere. It's really the final piece of a puzzle Qualcomm has been building for years. They've been acquiring leaders in edge computing, machine learning, and then, the big one, Arduino itself, giving them access to this massive global community. This is Qualcomm making a serious play to dominate the industrial IoT and edge AI space.
And the implication of that move is massive. With the UnoQ, Arduino is not just a little learning tool anymore. It is stepping directly into the ring as a challenger to Raspberry Pi, a company that has owned the single-board computer space for more than a decade. This is a real battle for the heart and soul of the maker movement.
This dual-brain approach just blows the doors wide open on what's possible. I mean, just think about it for a second. Running AI models right on the device for object recognition, hosting a full web server, processing high-res video, even running your own database, all on a board that fits in your palm. This stuff was pure science fiction for a normal Arduino until now.
So you've got two brains on one board. How in the world do you actually program the thing? Well, let's take a look at the software, because the goal here was to create one single unified development experience.
To handle all this complexity, Arduino created something called App Lab. The big idea is to give you one single environment where you can write Python code for that powerful Linux side, and then write the simple C++-based sketches that Arduino is famous for on the microcontroller side. It all happens in one place. Honestly, the best way to understand how these two brains talk to each other is with the classic Blink example. You know, the hello world of electronics. It sounds really simple, but it demonstrates the entire workflow perfectly. So here's how it works. On the Linux side, a Python script is doing all the high-level thinking. It decides when to blink the LED and then sends out a simple command like toggle. That command travels over a special communication channel, a kind of bridge, over to the microcontroller. And that microcontroller, it gets the command and bam, it acts on it instantly, toggling the physical LED with perfect predictable timing. So the computer thinks and the microcontroller acts. It's a really elegant system when you see it in action. Okay, so that's the promise, right? That's how it all looks on paper. But what's the actual real-world experience like for the makers who are getting their hands on this board right now?
Well, it's not quite plug and play just yet.
Early adopters are finding that right out of the box, you have to update the board's core software. And that means using command line tools and even connecting these tiny physical jumper pins on the board just to get started.
And for some, the software experience has been a real pain point. One developer described a pretty steep learning curve, fighting with crashing software and the complexities of something called Docker containers. Docker is a system that packages apps so they can run anywhere, but here it seems to add a layer of complexity that can be really hard to troubleshoot.
So here's the bottom line. The hardware itself is absolutely phenomenal. It's incredibly powerful. But that initial software experience can be a real challenge. This is definitely not a board for someone who's just starting their journey in electronics.
So, what's the big takeaway from all this? Who is the Arduino UnoQ really for? And what does it tell us about the future of making?
So who is this for? Well, it's for anyone who's ever hit the limits of a traditional microcontroller. It's for the student who wants to learn embedded Linux, the maker who's building a robot that needs to use computer vision, or the engineer prototyping an edge AI device that has to react in milliseconds. It's for people who need both a powerful brain and a fast reflex, all in one package.
And all of this leaves us with one last big question. As our creative tools get as powerful and complex as full-on computers, what does that mean for the simple, open-source soul that started this whole movement in the first place? What does it mean for the next generation of creators?